Today, I am going to discuss the following topics: the atmosphere, the types and sources of air pollution, and the effects of air pollution as well. So, first, let us discuss the atmosphere. The atmosphere is a mixture of gases that surrounds the Earth. It helps make life possible by providing us with air to breathe, shielding us from ultraviolet radiations coming from the sun, trapping heat to warm the planet, and preventing extreme temperature differences between day and night. Without the atmosphere, temperature would be well below freezing everywhere on Earth's surface. Instead, the heat absorbed and trapped by our atmosphere keeps our planet average surface temperature at a balmy 15 degrees Celsius equivalent to 59 degrees Fahrenheit. So some of the atmosphere's gases like carbon dioxide are particularly good at absorbing and trapping radiation. Changes in the amounts of these gases directly affect our climate. So the Earth's atmosphere can be divided or also called as atmospheric stratification into five main layers. So the first layer is the troposphere. We live in a troposphere. The troposphere is the layer closest to the Earth's surface, where most clouds are found and almost weather conditions occur. It extends from Earth's surface to an average height of about 12 kilometers, although this altitude varies from about 9 km at the geographic poles to 17 km at the equator, with some variation due to weather. The troposphere contains roughly 80% of the mass of Earth's atmosphere. It is denser than its overlying layers because a larger atmospheric weight sits on top of the troposphere and causes it to be most severely compressed. 50% of the total mass of the atmosphere is located in the lower 5.6 kilometers of the troposphere. The second layer is the stratosphere, where it is the second lowest layer of the Earth's atmosphere. It lies above the troposphere and is separated from it by the tropopause. Stratosphere extends from the top of the troposphere at roughly 12 km above the Earth's surface to the stratopause at an altitude of about 50 to 55 km. The atmospheric pressure at the top of stratosphere is roughly 1 over 1000 the pressure at sea level. It contains relatively high concentration of that gas. The stratosphere defines a layer in which temperature rises with increasing altitude. This rise in temperature is caused by an absorption of ultraviolet radiation from the sun by ozone layer, which restricts turbulence and mixing. Although the temperature may be negative degrees Celsius equivalent to negative 76 degrees Fahrenheit at the tropopause, the top of the stratosphere is much warmer and may be near as 0 degrees Celsius. The stratosphere temperature profile creates very stable atmospheric conditions, so the stratosphere lacks the weather producing air turbulence that is so prevalent in the troposphere. Consequently, the stratosphere is almost completely free of clouds and other forms of weather. However, polar stratospheric or nacreous clouds are occasionally seen in the lower part of this layer of the atmosphere where the air is coldest. The stratosphere is the highest layer that can be accessed by jet-powered aircraft. So the third layer is the mesosphere. It is the coldest layer because there are almost no air molecules there to absorb heat energy. There are so few molecules for light to refract off that the sky also changes from blue to black in this layer. Mesosphere extends from the stratopause at an altitude of about 50 kilometers to the mesopause at 80 to 85 kilometers above sea level. Also, the mesosphere is the layer of the atmosphere where meteors burn up into small fragments of dust if they fall towards Earth. So the thermosphere is the fourth layer of Earth's atmosphere that is directly above the mesosphere and below the exosphere. It extends from about 90 kilometers to between 500 and 1000 kilometers above Earth's surface. Temperatures climb sharply in the lower thermosphere, then level off and hold fairly steady with increasing altitude above that height. Solar activity strongly influences temperature in the thermosphere. The thermosphere is typically about 200 degrees Celsius hotter in the daytime than at night, and roughly 500 degrees Celsius hotter when the sun is very active than the other times. Temperatures in the upper thermosphere can range from about 500 degrees Celsius to 2000 degrees Celsius or higher. The boundary between the thermosphere and the exosphere above is called the thermopause. At the bottom of the thermosphere is the mesopause, the boundary between thermosphere and the mesosphere below. So although the thermosphere is considered part of Earth's atmosphere, the air density is so low in this layer that most of the thermosphere is what we normally think of as outer space. In fact, the most common definition says that space begins at an altitude of 100 kilometers, slightly above the mesopause at the bottom of the thermosphere. The space shuttle and the International Space Stations both orbit Earth within the thermosphere. Finally, the aurora, or the southern and northern lights, primarily occur in the thermosphere. Solar photons steer electrons away from the gas particles in the thermosphere, creating electrically charged ions of atoms and molecules. Earth's ionosphere composed of several regions of such ionized particles, referred to as the ionosphere. D layer, E layer, and F layer, overlaps with and shares the same space with the electrically neutral thermosphere. Charged particles such as electrons, protons, and other ions from space collide with atoms and molecules in the thermosphere at high latitudes, exciting them into higher energy states. Those atoms and molecules shed their excess energy by emitting photons of light, which we see as colorful auroral displays, the northern and southern lights. The sphere is the last layer of the Earth's atmosphere. It includes the uppermost region of Earth's atmosphere as it gradually fades into the vacuum of space. The air in the exosphere is extremely thin. In many ways, it is almost the same as the airless void of outer space. The exosphere is directly above the thermosphere. The boundary between these two layers is called the thermopause. The bottom of the exosphere is sometimes also referred to as the exobase. The altitude of the lower boundary of the exosphere varies from about 500 to 1000 kilometers above the Earth's surface, depending on the amount of incoming X-ray and ultraviolet radiation from the sun. So not all scientists agree that the exosphere is really part of the atmosphere. Some scientists consider the thermosphere as the uppermost part of the Earth's atmosphere and think that the exosphere is really just part of space. However, other scientists do consider the exosphere is part of our planet's atmosphere. Because the exosphere gradually fades into outer space, there is no clear upper boundary of this layer. One definition of the outermost limit of the exosphere places the uppermost edge of Earth's atmosphere around 190,000 kilometers, about halfway to the moon. At this distance, radiation pressure from sunlight exerts more force on hydrogen atoms than does the pull of Earth's gravity. A faint glow of ultraviolet radiation scattered by hydrogen atoms in the uppermost atmosphere has been detected at heights of 100,000 km by satellites. These regions of UV glow is called the geocorona. Now that we are done in the atmosphere, let's move on to air pollution types and sources. So air pollution refers to the mixture of substances in air that are damaging to human health and environment. It is also the contamination of indoor or outer surrounding, either by chemical activities, physical, or biological agents that alters the natural features of the atmosphere. So those harmful substances present in air is called air pollutants. Pollutants can be gases or particles and came from natural or anthropogenic sources. Particles can be solid like dust or liquid like water or a mixture of both. These pollutants can be categorized into two, the primary and the secondary sources, or secondary pollutants. So, when the pollutants came directly from a source, it is primary pollutants. This includes particles such as dust and industrial emissions, while secondary pollutants are created when a primary gas-based pollutant is oxidized by a chemical reaction. For example, when the volatile organic compounds are combined with nitrogen oxides, ozone, and fine particles such as PM2.5 may be produced. Now, let's discuss the primary pollutants and its major sources. First, we have the carbon monoxide, poisonous flammable gas that is colorless, odorless, tasteless, and slightly dense than air. Monoxide mainly came from combustion, including biomass burning in domestic wood heaters, prescribed burns and bush fires, motor vehicle, and metal manufacturing. Second, we have nitrogen dioxide and nitric oxide, together termed as nitrogen oxide. So its major sources is from the combination of nitrogen and oxygen during high temperature combustion of fossil fuels, from motor vehicle exhaust, and from electricity generations in fossil fueled power stations, petrol, and metal refining, food processing, and other manufacturing industries. Then the third, we have the sulfur dioxide that is composed of sulfur and oxygen. It is mainly came from electricity generations in coal-fired power station, metal smelting, or sulfurous ores including lead, copper, zinc, aluminum, and iron. Fourth, we have the particulate matter that includes both fine particulate matter or the PM2.5 and the coarse particulate matter or the PM10. So, fine particulate matter or PM2.5 came from combustion, chemical processes that can form in the atmosphere during chemical reactions as those involving secondary nitrates and sulfates and secondary organic aerosols. While coarse particulate matter or the PM10 mainly came from burning in domestic wood heaters, mining, and other uses, and also from road dust, sea salts, and wind-blown dust. Lastly, we have the volatile organic compounds that is mainly came from industrial application involving paints, solvent, and evaporative fuels. Also, the naturally occurring volatile organic compounds are emitted from vegetation and from those cleaning and personal hygiene products. Now, let's move on to the secondary pollutants. First, we have the ozone, which is composed of three atoms. Ozone came from atmospheric photochemical reactions of primary pollutants, nitrogen oxide, and volatile organic compounds from motor vehicles, industry, and natural sources. Second, we have the nitrogen oxide, which is a family of poisonous, highly reactive gases that form when fuel is burned at a high temperature. It is brown in color and emits from vehicle as well as industrial sources such as power plants, industrial sources such as power plants, industrial boilers, cement kiln, and turbines. Third, we have the particulate matter. It is also could be a secondary pollutant. It is a combination of solid particles and liquid droplets that can be found in air. Particulate matter contains hazardous elements such as arsenic, chromium, lead, manganese, and nickel. Now, if you have a question, just leave it on the comment section. Okay, now let's discuss my last topic, which is the effects of air pollution. So air pollution affects all things. It is harmful to our health and impacts the environment by reducing visibility and blocking sunlight,
causing acid rain and harming rainforest, wildlife, and agriculture. Greenhouse gas pollution, the cause of climate change, affects the entire planet. The first effect of air pollution is harming human health. According to World Health Organization, an estimated 7 million people die each year from an air pollution. More than 4,000 people died in just a few months due to severe smog event occurred in London in 1952. Ground-level ozone causes muscles in the lungs to contract, making it difficult to breathe. Exposure to high ozone levels can cause sore throat, coughing, lung inflammation, and permanent lung damage. Symptoms from short-term exposure typically resolve quickly, but long-term exposure is linked to serious illness and diseases in multiple body systems. Children, the elderly, and the people with ongoing illness are more vulnerable to air pollution than other groups. Urban population are also at greater risk due to high concentration of pollution within cities. Some short-term exposure to air pollution can cause coughing, wheezing or difficulty breathing, irritation to eyes, nose and throat, headache, dizziness, fatigue. Long-term exposure to air pollution can cause respiratory disease such as asthma and emphysema, cardiovascular damage, harm to liver, spleen, and blood, nervous system damage, cancer, birth defects, and death. Second, air pollution can harm animals and plants. Wildlife can experience many of the same negative effects of air pollution that humans do. The damage to respiratory systems is the most common effect on animals, but neurological problems and skin irritation are also common. Plants and crops grow less when exposed to long-term air pollution. Ozone pollution harms plants by damaging structures called stomata, which are tiny pores on the underside of the leaves that allow the plant to breathe. Sometimes some types of plant can protect themselves by temporarily closing their stomata or producing antioxidants, but others are particularly sensitive to damage. Between 1980 and 2011, $9 billion worth of soybean and corn were lost in the U.S. As a result of ozone pollution. When acid rain, lead toxicity, and exposure to nitrogen oxides change the chemical nature of the plants are robbed of the nutrients they need to grow and survive. This impacts agriculture, forest, and grasslands. Third, air pollution can cause acid rain. Burning fossil fuels releases sulfur dioxide and nitrogen dioxide mixed with water droplet in the atmosphere to make sulfuric acid and nitric acid. Winds can carry these pollutants for thousands of miles until they fall to the Earth's surface as acid rain, which damages the leaves of vegetation, increase the acidity of soils and water, and is linked to over 500 deaths each year. Buildings and other structures are also impacted by acid rain, which causes an estimated $5 billion of property damage each year. Acid rain dissolves mortar between bricks, causing stone foundations to become unstable, and is destroying ancient buildings and statues carved from marbles and limestones. The fourth effect, air pollution can reduce sunlight. High levels of particulate pollution from all types of burning reduces the amount of sunlight that reaches the surface and even changes the appearance of the sky. When less sunlight is available for photosynthesis, forests grow at a slower rate and crops are less productive. Hazy skies not only reduce the visibility but also impact the weather and even the climate. Fifth, air pollution can make a hole in the ozone layer. The hole in the ozone layer is caused by air pollutants. Chemical use as refrigerants such as chlorofluorocarbons or CFCs contain chlorine atoms. Releasing chlorine atoms in the atmosphere destroys ozone. A single chlorine atom can destroy thousands of ozone molecules. The ozone layer blocks harmful ultraviolet B radiation from the sun, and it protects us in a way that is similar to putting sunscreen in your skin to prevent sunburn. The ozone hole puts all living things at risk by increasing the amount of UVB that reaches the surface. Exposure to ultraviolet radiation increases the risk of skin cancer in humans, restricts growth and development in plants, slows the development of fish and amphibians, and reduces the number of phytoplankton in marine ecosystems. Ultraviolet radiation also causes natural and synthetic materials to break down at an accelerated rate. So air pollution can affect to adding too much nitrogen on land. Gaseous ammonia from agriculture and nitrogen dioxide from truck, car, and airplane emission increase the amount of nitrogen in soils. Plants need nitrogen to grow, but too much nitrogen can limit the growth of some plants and increase the growth of others, disrupting the balance of species within an ecosystem. This disruption is negatively impacting grasslands and other fragile environments around the world. So last is the effect of greenhouse gas pollution. Greenhouse gas pollution is causing climate change. As a result, ecosystems are changing faster than plants and animals can adapt, and many species are going to be extinct. Marine ecosystems are vulnerable to ocean acidification because when carbon dioxide emitted into the atmosphere is dissolved in seawater. Ocean acidification makes it difficult for many marine species to grow shells and skeletons. Also, melting of ice sheets, warming ocean, and extreme weather conditions are examples of how climate change caused by greenhouse gas pollution threaten ecosystems across the earth. In many cases, the decline of one or a few species due to air pollution can topple the balance of entire ecosystem. That's all. Thank you.